Today's smart contract audits are mostly PDFs and trust. A team says this contract was audited. An auditor says these checks passed. But there is no machine verifiable link between the claim and what was actually tested. And there is another problem. The auditor usually cannot publish the full test suite. That test suite is their intellectual property. It also reveals what was covered, and more importantly, what was not covered. zkAudit solves this with zero-knowledge proofs on Stellar. Here is the flow. An auditor runs a private audit suite against a contract off-chain inside RISC Zero. The proof reveals only a small public journal, the hash of the target contract, the commitment to the private test suite, and the score. K test passed out of N. Then, on Stellar, our registry verifies the Groth 16 proof through the Nethermind RISC Zero verifier router. If the proof is valid, the registry writes an on-chain attestation, so the score is public and verifiable, but the audit suite stays private. Now let's run the end-to-end demo. This script deploys the demo flow and walks through the main cases. First, we attest version 1 of the contract. This is a simple vault with 3 intentional bugs. The proof is verified before the attestation is written on-chain. Now we call get_attestation and we can see the result. 7 out of 10 checks passed. This is not a self-reported score. The registry only records it after the verifier router accepts the proof. Now we attest version 2. In version 2, the same 3 bugs are fixed. The same private audit suite runs again, and now the result is 10 out of 10. The important detail is the suite commitment. It stays the same across both versions. That means both contract versions were judged by the same private test suite without revealing the suite itself. And this is not just local output. Here is the transaction on Stellar testnet. The attestation was actually written on-chain. Now the important part, why zero knowledge is load-bearing here. If we remove the proof, the system becomes just another Trust Me registry. So the demo includes 2 negative cases. Both must fail. First, a forged journal. Here we take a valid-looking result and change 1 byte, for example turning 10 into 11. The registry hashes the raw journal bytes. That digest no longer matches the digest inside the proof. So the verifier traps, the transaction rolls back, and the fake score cannot be written. This proves that you cannot publish a score the proof did not actually produce. Second, a valid proof from the wrong engine. The proof itself is real, but it comes from an engine that is not registered in the allow list. The registry rejects it with engine not registered. That matters because an audit score only means something relative to a trusted audit engine. A valid proof is not enough. It must be a valid proof from an approved engine. The current scope is intentionally honest. Right now, the audit targets are Rust modules compiled into the RISC Zero guest. They are not arbitrary deployed WASM contracts yet. The production path is clear. One stable guest becomes a WASM interpreter. It takes the contract WASM as input, audits real deployed Soroban contracts by hash, and keeps the same journal format and the same registry. That gives us a stable image ID, private audit suites, and public verifiable attestations. Everything shown here runs on Stellar testnet, and the links and commands are in the README. Thank you for watching.